Good evening, all. So before I start, can anyone please confirm whether my voice is clear, whether the screen is visible or not, right? Yes. Yeah. So what was just we have quick review what we have discussed yesterday, right? Yes. Apache Spark, why PySpark made for Spark. Okay, Apache Spark, it's an open source distributed cluster computing platform in parallel process style with in-memory computation used for large scale data processing, right? I can say it's a general engine for big data analysis, right? And for processing and computation. And it's a Python API to use Spark. It is used for distributed SQL, creating data pipelines, ingesting data into databases, running machine learning algorithms, and for graphs and data stream. So, and what is the need for PySpark? It's a lightning fast technology, right? It's for design for fast computation, and it's one of the most demanding tool among data engineers, right? So where we work with the bigger data sets like that. So we see a lot of data is getting generated through offline and online, right? So where we see a lot of data in hidden patterns, unknown corrections, right? Customer preferences. So we extract the useful insights from it, valuable information from the raw data, right? So already we have many tools, but they are not that much of appealing. But PySpark, it's a very fast tool, right? Flexible tool for cracking this big data and gain benefit from this, right? So the combination of Python and Spark is the very efficient way for the world of big data, right? So Apache Spark community came with a tool called PySpark, that is Python API to use Spark, right? So by Spark by default built using Scala, but Scala and Python are mostly preferred today. But today, like Python, Spark with Python has got great boom, where it has got many libraries, modules available, right? Python has got huge community as compared with Scala, and it's dynamic type, contains powerful libraries for ML, machine learning, graph streaming. Yes. And main features we see is in-memory computation, with storage and processing happening within the memory level, and lazy evaluated means whenever you perform an action, then only the entire data flow gets executed. Powerful fault tolerance model. It's a powerful fault tolerant model, right? Yes. Means I will be discussing in brief about this fault tolerance. Means if any slave goes down during the processing, if data is processed by multiple slaves, if any one slave goes down, then how Spark can recompute, right, and get that lost data, right? Immutable means changes, modifications not allowed to the data object. Reusing the already executed transformation, that's what we call persistence, and mostly used within this commercial sector, right? Yes, especially in the banks and in financial systems, right? Financial fields for retrieving the customer profiles, their information, analyzing the useful insights to make in taking the right decisions, right? And Spark, it has also plays an important role in fraud detection, means by using machine learning tasks techniques, right? Yes. And even in the healthcare also, right, predicting who is means you are just going to predict who is going to face that issue or problem, right? Which patient is going to. And in the entertainment industry also, right, mainly like online streaming, right? So in Spark, there is a Spark streaming concept, right, where we see like micro batching for every. I doesn't want batch. Batch is different. Micro batch is different, right? In Spark, we see micro batching. I want quick updates for every 2 seconds or every 5 seconds. I want updates. We call it as a micro batch. So I said even for this online streams, like today, even entertainment industry is moving towards the online streams, online streaming, like especially Netflix uses Apache Spark for real-time processing, right? For this online movies or for web series, and it's processed nearly approximately 450 billion events per day, right? Yes. Even within this e-commerce, trade, and in tourism, right? This preferred. Spark can run on any cluster, right? Hadoop, AWS, Mesos cluster, and resilient distributed data sets. I'll go back. I'll come back to this resilient distributed data sets, right? Before that, we have to compare the Spark with other technologies, right? First, we talk about this Hadoop generations. Execution generations, right? If we talk about Hadoop execution generations, we got like MR, MapReduce, second like MR2, Sage, Spark. MR, MR2, Sage, and Spark. MR, MR2, Sage, and Spark. Okay. So this MR, okay, in this Sage and Spark, MapReduce execution model. Previously, we used a lot of MapReduce execution, but it's got outdated today. We are going with Spark, and here a lot of coding is in MapReduce. Sage and Spark, right? Right. So what is the Sage and Spark?
So what is this execution generation? What does that mean?
Execution for processing, right? We are using MapReduce, Sage, Spark execution models. If we talk about in total Hadoop MapReduce execution is going to happen. Spark is there, Sage is there. These are the processing systems, models, execution models. Talk about
while Spark does all this data pipelining and other stuff, it doesn't use MapReduce, or it's independent?
MapReduce execution model is totally different.
Oh, okay.
If our mapper phase, reducer phase, partitional phase, short supply phase, like we have got different phases. That is total execution model is different. Spark execution model is different.
Okay.
Spark, MapReduce is not okay. Spark is totally a data flow DAG model. It follows a DAG model, directed acyclic graph model. See, both Sage and Spark, observe this, both follows DAG model. Which one? Sage and Spark, DAG, directed acyclic graph. I'll discuss more on this DAG, but directed acyclic graph both follows DAG model. But Sage is not in memory. Sage is not in memory.
Yeah, Vijay. Tej is completely on the Hive engine, right? So what you are using here, it's related to Hive, right? Completely Hive engine upgrade, that one, right?
Yes. That's what I was talking. But I would just compare the Sage and Spark, both comparisons. So if you talk about Sage and Spark, both follows DAG model. But both follows directed acyclic graph model, but Sage is not in-memory computing.
Okay.
But Spark has in-memory, but Spark has in-memory computing. Spark has in-memory computing, which has high speed. As compared to Sage. Other in-memory computing systems in the market, right? So what are the other in-memory computing systems? other in-memory computing systems. You talk like
HANA,
SAP,
SAP HANA.
SAP HANA, right? Yes, other in-memory computing systems, SAP HANA. If we talk about if we compare this Spark and HANA, we compare this both Spark and HANA. Both are in
Yes.
memory. Both are
Both.
in memory.
The HANA mainly they use for SAP for the report generation. But Spark mainly they use for the general purpose, not in the SAP.
So both are in-memory computing systems, but HANA is not, mainly if you see, HANA is not a distributed. But Spark is a distributed. Spark is distributed, right? We will get distributed RAM here. Spark is distributed. HANA is not distributed. So if you keep on like in Spark, right, it can accommodate the bigger data sets. Even if the everyday data is coming, right, even it can support the data. It can store across, it can distribute the data across multiple systems and can process, right, faster. So it's distributed RAM. It's divided into partitions. Partitions are distributed across different worker nodes of the Spark cluster, and huge data sets also can be loaded into this, right? Okay. So there is a component in Hadoop, Apache Pig. Apache Pig, right? And Spark. If you heard previously, like Pig is a Pig Latin language. If you see in 2013, 14, 15, right, Apache Pig was mostly used with Latin language. So both are data flow languages only. Both are data flow languages. But both are data flow language, but but in Pig, entire flow one MR job. In Pig, entire flow is treated as one MR job. Again, MR has got drawbacks. And MR has got drawbacks. The drawback, see, you can say Pig and Spark both are data flow languages. But MR has got drawbacks. And if you say mainly in Hadoop, MapReduce happens, right? MapReduce processing is going to, you are going to see in Hive MapReduce execution, in Big MapReduce processing, see any component of Hadoop, even like Scoop MapReduce execution is going to happen. So if you talk like MapReduce, Spark, MapReduce and Spark. So if we say, what are the drawbacks with MapReduce? Drawbacks with MapReduce. Anyone? Drawbacks with MapReduce means total Hadoop follows MapReduce execution model. Drawbacks.
More bytes.
Because MapReduce follow the MapReduce with Java programs. And also it will consume the time for the execution and for the result. And it will be mainly work on the cluster environment.
First,
Doesn't consume the memory.
IO
Is it-
operations are more others.
transformations cannot be, first thing is transformations cannot be reused. Means, for example, we take a simple transformation, right? If you want department numbers are there, department number, marketing department, HR department, finance department. I want what are the total salaries given to each department. And next I want to perform another task. what is the max salary given in each department. If you want this task, right, already you need to extract that salary field. Department number, department and the salary. These two columns you need to extract. Already extracted. In the first task, already both are extracted. After extracting, next you're performing some aggregation. Later I want to perform max aggregation. Then if you are performing some different aggregation, again we need to come from the starting. We cannot use mapper, mostly transformation happening in the mapper level, right? So, but transformations can't be reused. Again, we need to come from the beginning, from the starting, right? We need to execute mapper without executing mapper directly, you can means so this sum aggregation, max aggregation, min aggregation, all this happens within the reducer phase in map reduce. But already mapper output, I can take, can I perform another task means no. You cannot take mapper output and perform different operation. Means if you have got mapper output, the same mapper output can be used for by 4 operations, but I cannot use it. Mapper output, you cannot use it and go with the reducer, right? Compulsory without executing mapper, you cannot go with reducer. That is the main drawback. Transformations, whatever transformations you do within the mapper level. Map reduce means 2 phases are there, mapper, reducer. In mapper, whatever transformations you do, the same output of the mapper, if you want to reuse by another, you cannot. Compulsory mapper has to be executed even, right? That is the first. Secondly, not a flexible parallel process, not a flexible parallel process. Means MapReduce is a good, it's a excellently designed, right? So, but it's meant for parallel processing. But can I execute a mapper and reducer both parallelly? Mapper output is taken as input by reducer, right? I cannot execute both parallelly. But here what we are saying, MapReduce is meant for parallel processing, but they are executing first mapper phase, that output is given to reducer, then reducer phase executes one after another. Right? It's not a flexible parallel process. And mostly like if you want to go for ML, machine learning kind of things, right? Bad, it's bad. MapReduce is bad for iterative algorithms. So today, like if I want to, you work with this right? Bad for iterative algorithms, or most of these ML algorithms are iterative in nature. Most of these are iterative in nature, right? Yes. But MapReduce is bad for iterative algorithms. Slow processing. Slow as compared with Spark. Slow as compared with Spark. Same. Yeah, here in the MapReduce and Spark, if we compare, right? So Spark sorted. $100 TB of data. Spark sorted 100 TB of data using 206 nodes. Spark sorted 100 TB of data using 206 nodes in 23 minutes. Previous world record was set. Previous world record was set by Hadoop MR cluster, Hadoop MapReduce cluster, using the 20 in 72 minutes. In 72 minutes, but it has used nearly 2100 nodes, right? Even though it has used 2100 nodes, it was set in 72 minutes, right? Right, but Spark in just it has used 206 nodes, 23 minutes. So Spark 100 times faster, 100 times faster than MR, faster than MR within memory, right? In memory.
So one question, when compared to Hadoop, where what do you say, reusing transformation might not be easy in Hadoop, but if we consider Spark, a majority of the transformations, in the sense wherever the data is being split and it's been divided into multiple data sets and other stuff, they are in memory. Okay, how whether these transformations can be reused for other computations and other stuff?
Yes, in Spark Compass, definitely. In the today's session itself, I'll give some examples, right? How transformations we can do. We have got a feature. Yesterday also I said one feature, right? Persistence. Reusing already executed transformation. Persistence feature in Spark.
Okay. By default, all the transformations are persistent.
So whichever you want to be reused, we need to persist it.
Okay. Right.
Whichever you want to be reused, you can persist so that it can provide output to many different flows.
Okay.
So here, if you compare, right, if comparing with the Hadoop MapReduce with the Spark 100 times faster, but within the disk, it is 10 times faster, right? Yes. Okay, and I was just saying, okay, I'm sorry. Spark and Flink. Spark and Flink, right? So in the earlier, when after introducing Spark, right, there was one more product introduced by Apache family, right? Flink. In the initial stages of Flink, it has dominated Spark, but later Spark has got powerful libraries, right? So both are from Apache family, right? Yes. Both purpose and objective is same. Both purpose and objective is same, right? Yes. If we talk like in the initial versions of Spark, in the initial versions of Spark, right? That is initial versions, sorry. That is before, I can say before Spark 1.6. Before Spark 1.6, it was weaker. It was weaker in ML, library, right? Yes. So if you see, if mainly if ML library means the heart of data analytics. Heart of data analytics is ML. But from Spark 1.6, but from Spark 1.6 version, Spark introduced powerful libraries for all components, for all components. Okay. From Spark 2.0 version. Spark dominated Flink. So here before 1.6, observe this, before 1.6 version. Spark, I can say like Spark is weaker Flink. Spark less than Flink. After 1.6 version. Spark became Spark. After 2.0 version, after Spark 2.0 version, Spark dominated Flink. Right. Okay, now discussing about, right, these are the advantages as compared with Flink, Sage, HANA, Pig, MR, right? How Spark has got advantages, mainly in memory computations, persistence features, transformations, that is what transformations can be reused, lazy evaluated, means on demand it's going to get executed, right? Yes. Next, coming to this resilient distributed data sets. Resilient distributed data sets, Spark data objects are called RTDs. RTs subdivided into partitions. These partitions are distributed across multiple RAMs of multiple worker nodes and are processed parallelly, right? Yes. So RTD programming style is data flow. Data flow is the sequence collection of pipes. At each pipe, any data operation such as loading data, filtering data, transforming data, merging data, sorting data is going to happen. So one more important thing, right? In Spark, observe, in Spark, data flow is executed. Data flow is executed in a sequence. Data flow is executed in a sequence. It's executed sequentially. It is executed sequentially, that is RTD by RTD, RTD by RTD, one after the other. Data flow is executed sequentially, that is RTD by RTD, one after the other, right? With in-memory computing feature, and persistence feature. With in-memory computing features and persisting feature. But observe here, but if a RTD is divided into 20 partitions, then all those can execute parallelly. See this RTD divided into 20 partitions stored across 20 RAMs of 20 worker nodes and are processed parallelly and gives output to the next one. See one data flow, right? Just I'll give an example, right? Just before you have asked, how can we reuse that executed transformation? So just observe this clear diagram. Yes. Observe this flow, right? And try to send R1, RTD1, R1, R2, R3, R4, R5, R6, R7, R8, R9. Totally, how many flows you observe in this? R1, okay. 3 flows you can observe, right? First flow. Observe this first flow. R1, try to answer. R1, R2, R3, R4, R7. This is the first flow. Second flow. 3 flows. R1, R2, R3, R5, R8. Third flow. R1, R2, R3, R6, R9. R6, 3 flows, right? To execute any flow, we need to perform an action.
Here R is an RDD.
Or
What is R here?
RDD1, RDD2, RDD3, RDD4, and
So RDD, this R1 and other this data is further again split into partitions at each and every stage, right?
at R1 partitions will be divided into partitions. They will be distributed and they are going to be processed. Their output will be given as input to the next R2.
Okay.
Next, similarly, R2 partitions will be distributed and stored.
Okay.
It doesn't mean that all R1, R2, R3 will have the same number of records. They'll differ, right? So for example, executing flow 1. I want to execute the flow 1. So here, executing flow 1. I want to perform an action, then only the flow 1 executes. So R7 dot action, R7 dot action. If I perform action, then it executes from the root. Now, first R1 loads, R1 output is given as input to R2. Next, R2 output is given as input to its output given as input to R3. R3, R4, R7, right? R3 output, R4 output to R7. So this output is given as input. Right, in this way. So here observe carefully. When already R1 is an RTD with bigger data volume, R1 is an RTD with bigger data volumes. Think that here R1 to R7, but think that R1 to R70, 70 RTDs. Do you think all the RTDs will be in the RAM?
Yeah, I think in this case we can persist R3 and we can start
All the
operation.
RTDs, my query is, all the RTDs will remain in the RAM? To execute this flow, first flow, do you think all these RTDs will be in the RAM?
No. Output will be in.
So here R1 already R1 RTD is a bigger data value. Okay, it's think that you got some huge data, it's a new data object. So R1 output, once R2 collects that R1 output, whatever it is, when R2 is ready and R2 is loaded, computed, R1 gets removed from the RAM. When R2 output is collected as input by, means in R1, I perform some filtering operations. There are 10 lakh records or like 10 crore records are there. From the 10 crore records, just I want only particular city, Hyderabad city data only I want. Filter condition you can give, and the filter condition now R2 out of 10 crore records, only 1 lakh records belongs to Hyderabad. Now R1 has got 10 crore records, R2 has got just 1 lakh Hyderabad records. You got from R1, you got R2. R1 output is 1 lakh. That 1 lakh is taken as input by R2. On that R2, again, what I will do? Some transformations I have. Again, if you want to filter further, I want in that Hyderabad, I want only particular department. If 5 departments are there, only particular department data I want. Again, you filter, right, based on department number equal to some 11 or 12 or 13. Again, data gets filtered. In this way, you keep on one output is input to the next flow. When R3 is ready and computed, R2 is going to get removed. When R4 is ready and computed, right, and R3 is going to get removed from the RAM. When R7 is ready and computed, R4 is going to get removed from the RAM. When the R7 output is collected, once the R7 output is collected, R7 also is going to get removed from the RAM. Now, what is there in the RAM? Which RTD present within the RAM?
So
Which
only the currently processing RTD possibly would be in RAM, others would be persisted. That's
Yeah.
good.
Others will be removed.
Mhm.
So here, once the total or execution is completed, the last RTD also removed. Now what is it? When execution finished, this P4, this R7 also removed. No RTD in the RAM. No RTD in RAM. Next, you can trigger the next flow. If all the RTDs, if R1, R2 will be stored in the RAM, then the other RTDs can't be accommodated. If the RAM is filled with the RTDs, then the upcoming RTDs can't be accommodated. Right. So all the RTDs won't be within the RAM, right? Only one RTD by RTD. So I said, just before I said, RTDs are going to get executed sequentially, not parallelly. All the 7 RTDs execute parallelly. No, right? R1 output to be given to R2. R2 output should be given to R3. Until R1 processed, R2 cannot start its execution. Once R2 is processed, R2 output is given to R3, then only R3 can compute. R3 computed, then only it can give its input to R4.
Yeah, Vijay, here parallel means like R1 partitions are going to be executed parallelly. That's all right. but
Yeah,
not
if
R1 to R7.
R1 is a bigger data object.
Right.
R1
yeah.
is a bigger data object in GBs or TBs of data, right? It has got some 70 partitions or 90 partitions. Those partitions will be executed parallel.
Parallel.
And
But
gives
not
out-
like from R1 to R7, not in parallel.
So during the process, right? So either this R1 will be processing within the RAMs. Once they are processed, the output will be given to the next R2. So only the partitions will be executed parallelly. But two arteries won't never execute parallelly. Okay.
And in MR also like happening the same, right? First like a map is executing and like next like no, not
Mapper and reducer phase. But here, if you take one data object, entire data object is going to be stored across multiple and executes.
right.
Total data is going to be processed parallelly. And the output will be collected by the next one. But there, entire data, first mapper, then reducer. Okay, next see the next flow. And here one drawback I'll show you and how it is Spark rectifying it. So here is executing the second flow, flow 2. If I want to execute flow 2, what I need to do? If I want to execute this flow 2, this is the flow 2, right?
Right. R3 we need to persist on the either
And
RAM or
this is
You have to give 6 R8 action. You have to
R8
run.
dot action. R8 dot action, if you say, then only from the root it will start from R1 to R8 it will start and R8 output will be collected. See, okay, here if I talk R1, R2, R1, R2, R3, R5, R8. So this output as input to R2, this R2 output as input to R3, R3 output as input to R5, R5, R8. When
but every time need not go to like R1, R2, right? In this case, is that mandatory?
I'll come back. When R1, R2. When R2 is ready, R1 gets removed. When R3 is ready, this is going to get removed. This is going to get removed. When R8 is ready, R5 removed. When the total execution is completed, R8 also removed from the RAM. No RTD in the RAM.
Sir, is R8 action bracket is a command?
Action. I need to perform action on what?
Sir, is R8 action is a command?
R9 dot action. R9 dot action means many actions are there. Any one action you can perform. Inbuilt actions are there. I'll discuss. R9 dot one action like R9 dot collect. Collect is an action. It is going to collect all the R9 output. If I say R9 dot collect, then only or R9 dot action, whatever action you do, then it will start from R1, R2, R3, R6, R9. So one by one, RTD by RTD, they get loaded and they will be removed. When R9 is ready, R6 removed. When the total output is collected, R4 also removed. Here, what is the drawback you observe? Here in the above flow, every
Yes,
time it is
R1,
re-executing.
R2, R3 is 3 times, right? It is timeless.
So in this flow, you see these 3 are common.
Yeah.
The 3 flows, these are common. Every time it is re-executing from the beginning, even though you have got the same flow. So to avoid this, right, Spark identifies the RTD whose output is commonly used by, is regularly used by many flows, and make it as persist and persist it so that its output will be available to other flows. In the above example, which RTD output is used by many flows? Identify the RTD whose output is used by many flows in this example. Which
R,
RTD output is used by many flows?
R3 RTD.
R3 output is used by many flows. Persist it can. Persist. R3 dot persist. So make R3 as persist. So we no need to execute from the beginning. So we no need to execute from the beginning. Yes, we can just start from R3. Where R3 is available, it is going to give the output, right? R3 remains in the RAM, even though its next RTD is ready. Yes. Now observe this flow, right? Now, 1 second. See this flow fast. R1, R2. Okay. Now I am persisting R3. R3 is persisted. R3 is persisted means R3 remains in the RAM, and R3 will be available in the RAM and provides output to the other flows. Now,
I have a question.
yes.
In PySpark programming or Spark programming, we are using data for the DF, right? So already it is already in under the maintenance means how come it is?
Data frame means RTD with schema. RTD with schema. Schema RTD we call it as a data frame. So generally RTDs doesn't have schema. That's the problem. So if you are providing RTD plus schema, is nothing but a data frame. What do you mean by data frame? Schema RTD. RTD with schema. RTD and providing schema both combinedly we call it as data frame. Means in the form of structured format you will be getting. Data frame means you'll be getting in a structured format. Right? Flow 1. So RTD, how to create a data frame means RTD dot 2df. That's it. And RTD 2df and provide the schema here. You will get a data frame. Yes. From RTD only, we are going to get data frames, right? Yes. Now observe this flow 1. R1, R2, R3. So flow 1 means I need to say what? R7 dot action. R7 dot action. R7 dot action means I need to start from the beginning or how it starts. R7 dot action means how the flow is going to start.
From the beginning.
R7, see, whenever you say R7 dot action, first you searches from where R7 is going to get the input. R7 input is R4.
R4,
R4 input is
R3.
R3. Is R3 available in the RAM? No. R3 input is R2. R2 input is R1. R1 input is file. From where you loaded the file, file to R. So from here onwards, it will start. From here onwards, it will start, right? So up to R7. So to execute this R7, so all this has to be executed, right? So it will start from R1 to R2 to R3 to R4 to R7. When this is ready, this is going to be ready. When R3 is ready, R2 gets removed. And now I am persisting. Now R3 is going to get persisted. When R3 is loaded into RAM, now it gets persisted immediately. R3 is persisted. R3 is persisted. R3 is persisted, and when R4 is ready, R3 won't be removed from the RAM. It's still available. When R7 ready, R4 removed. When the total execution completed, R7 also removed. Now, what is there in the RAM? R3 in RAM. R3 in RAM, right? First flow you need to be executed from R1 onwards. That's compulsory. If you want to persist an RTD, at least one flow has to be executed from the start to last. Now, during that flow execution only, which RTD you want to persist, that will be persisted.
My question, when you persisted, automatically R3 will be there in the RAM, right? Means we don't need to run any action on R7 or R8.
See, whenever, if you want to execute the first flow, if you want to execute, they won't be executed until you perform an action. That is what lazy evaluates. So if you want to execute any flow in Spark, compulsory some action you need to perform. If I say R4 dot action, R4 from R1 to R4 it executes. If I say R2 dot action, from R1 to R2 it executes. R3 dot action from R1 to R3. R7 from where I need to. Compulsory you need to perform action, then only the data flow gets executed. Now, okay. When a RTD will be persisted, you need to clearly understand when a RTD going to be persisted means during the one by one RTD will be loaded. During that loaded process, the RTD will be persisted. Whenever R3 loads for the first time, it gets persisted. Until then, it won't be persisted. Don't say R3 dot persistent, immediately R3 will be persisted. No. So whenever, yes. Whenever R3 loads for the first time, it gets persisted. Now, when R3 loads here, then only it will be persisted. So next one. Now R3 remain in the RAM. Now flow 2, if I want to execute the flow 2, right? I want to execute the flow 2. Now try to answer from where, what is that action I need to do? Or try to answer. I want the sessions to be interactive.
R8
R8.
R8 to R.
R8 dot action. R8 dot action. If I say yes, from where the flow need to will be starting here, R1 to R8 or R3 to R8.
R3 to R8.
First, it will start R8 dot action means first it will check that R8 has to get the input from
R5.
R5. R5 input is
R3.
R3 in RAM, right?
Persistence.
R3 in RAM.
Yes.
So directly R3 output I can use. So the flow is R3 giving output to R5, R5 to R8. No need to execute for R1, R2, all this again. So we are already reusing the already executed transformation output and computing the remaining flow. So when R5 ready, R3 will be available. When R5 ready, this will be removed. When total execution finished, this also. Now still R3 in RAM. R3 in RAM. This what persistence. How can we use the already executed transformation is in this. Now flow 3, you see. In the flow 3, I need to perform action, right? What is that? Or R9 dot action means the flow will start from where to where?
R3 to R9.
R3 to R9. First, we will check R9 input is,
R6.
R6 input is
R3
R3. R3 input is
in RAM. In RAM memory.
R3 is in RAM. R3 in RAM. So the flow is R3, R6.
R9.
When R9 ready, R6 removed. When the total execution complete, R9 also removed. R3 in RAM. R3 in RAM, right? Yes, that's fine. In all the above flows, even if the flow executions are completed, still R3 remains in the RAM. And so yes. So now all the executions completed. So the flows, but here how it is advantageous means, for example, R1, R2, R70 is there. R70 is in this way, in this way, in this way. 3 flows are there. First flow compulsorily we need to execute, right, to persist this R70. Or compulsory one flow should be executed. So then next during this process R70 gets persisted. But from next flow onwards, you no need to execute. Second flow 2 executes from where? R1 or R70?
R70.
Directly 70 steps are decreased. Already this executed transformation output we are using and going to go execute other flow. And here, this flow also. No need. Flow 3 also, if you want to execute, no need. 70 steps are getting decreased. And here in the above example, in all the 3 cases, all 3 remains in the RAM. Now, if R3 is not required, now total execution is finished. Just it's not required now. I doesn't want R3 within the RAM. Now all that total processing is finished. Now I doesn't want R3. You can forcefully remove it. Forcefully unpersist it. Unpersist it by saying R3 dot unpersist. R3 dot unpersist means immediately it gets unpersisted, removed from the RAM. Persistence won't happen immediately, but unpersistent happens immediately. How persistence happens means, once if you want to persist R7, once R7, R1 should load, R2 should load, R3 should load, R4, R5, R6. When R7 turn comes, then it will be persisted. There are 3 ways to unpersist an OTD. There are 3 ways to unpersist an OTD. Okay, forcefully unpersisting, right? Forcefully unpersisting, R3 dot unpersist. 3 ways to unpersist, right? There is one way. Second way, whenever session closed. Third is when server shutdowns. When session, this first one. Second is whenever the session is closed. When server shutdowns, right? So that RT will be unpersisted, right? Yes. So yes, I've got some queries, right? Coming back to this. Some questions or queries, right? What are the situations? What are the situations, for example, where RTD will be removed. What are the situations where RTD will be removed from the memory?
Forcefully and persist.
What are the situations where RTD will be removed from the memory?
Shutdown. And
Where
session.
RTD will be removed from the memory. And second, right, what are the different ways to persist in RTD? Different ways to unpersist an RTD. Generally, which RTD to be persisted? What is persistence? What is lazy evolution in Spark? Generally, which RTD to be persisted? What is persistence? What is lazy evolution in Spark? Now, what are the situations where RTD will be removed from the RAM, right? What are the situations, right? Where RTD will be removed from the RAM? Anyone?
After getting result,
Yeah. When execution is completed. When execution is completed. The last RTD will be removed from, right?
yes.
The last RTD will be removed. Will be removed from RAM. That is one. What is the another? General.
Session comes.
When next RTD is ready. When next RTD is ready, previous RTD gets removed. Previous RTD gets removed. Different ways to persist in RTD means RTD dot persist is one, that what we are saying. RTD dot catchy. So here RTD dot catchy means it can make use of only memory option. RTD dot persist can you make use of even you can persist in disk option, memory option, memory and disk option. Many persistence options are available. It can make use of many options. It can use only one option in memory option only, not in disk, right? So different ways, two ways. Later I discuss the difference between these two. Different ways to unpersist, three ways I said. Three ways. What are the three ways? Forcefully unpersisting. Forcefully unpersisting. Means by saying RTD dot unpersist. RTD dot unpersist. Secondly, when session is closed. When session is closed. Third, when server shutdowns. Now, generally, which RTD persisted means whose output, whose output is commonly used by multiple flows, whose output is commonly used by multiple flows. See, my total, I'll be spending more time with the data frames concept. I'll give some knowledge on these RTDs. Now, more than RTDs, data frames are mostly used, but data frames I'll be spending more time. I'll be discussing each and every data frame APIs. Right. Whose output is commonly used by multiple flow. That RTD output, that RTD we need to persist. What is persistence means? Persistence is nothing but making an RTD to be available in the RAM. Making an RTD to be available in, making an RTD to be available in RAM. That's making an RTD to be available in the RAM, right? Lazy evolution in Spark. Lazy evolution I'll be discussing, right? So lazy evolution means executing the data flow only when action is performed. Executing the data flow only when action is performed. All right. So these are the things. Generally, initially all RTDs are declared. One by one RTD, they will be loaded into RAM. One by one RTD will be loaded into RAM only when action is performed. And when action is performed, flow execution will start from its root RTD. During this flow execution, right, the partitions data will be loaded into RAMs, computed at RAM. Once RTD computation is over, it waits for its next RTD. If next RTD ready, then previous one gets removed from the RAM. So this process is going to continue till the action is completed, till the execution is completed or the action is done. When action is performed, okay. So during the flow execution, the one which is commonly used by many flows, that one will persist, and the remaining, right, the one which is commonly used by multiple flows will be persisting. Finally, once the RTD, once that output is collected, right?
Catchy and persist both are same, or if you do persist, it will be there main memory. If you do catch, the data will be there in the catchy memory.
So, there are two methods, persist and catch, are two methods for persisting an RTD. So I'll be discussing, there are many persistence options out there. Memory only, disk only, memory and disk only, memory underscore SCR only, disk underscore SCR only, right? Multiple options are there. Means there are nearly 5 options are there. This persist can make use of all the 5 options. This can make use of only one option, that is memory only option. If there is no sufficient memory, your job is going to be failed. But in this case, if there is no sufficient memory, then it will be persisted in the disk. Means multiple options it will be using. We will be specifying within this bracket which option we want. Right? We'll be discussing more on this persistent catch related difference. But before that, we have got some other discussions, different ways of persisting. What are the rules in persisting? And which order did you, right? And what are the persisting options? Right? Understood, right? RTD, the Spark data objects. Spark data objects, we call it as RTDs. Okay, fine. So we'll be discussing in brief, I said, right? about this PYSPARK. See this again, right? RTD computations, RTD persistence features, and persistence options, memory only, memory underscore SCR, disk only, disk underscore SCR, fault tolerance model, different ways of creating RTDs, creating Spark objects from Scala, right? Groupings, aggregations, various actions and transformations, different types, inbuilt actions and transformations. Now, data frame, PySpark SQL. So if you want to work with pure SQL kinds of statements, data frames, various data frame APIs, data frame API, right? Using maps and making the data structures, creating data frame, RTD to data frame, convert data frame to pandas, structure type, row class, column class, collect with column, where filter, order by sort, group, join, union by name, map, flat map. So many other, you don't need to write huge codings, right? Inbuilt functions are available, right? Partition by map, by array type, and separate functions like aggregate function, window function, date and timestamp functions, JSON functions, and working with different file formats and PySpark inbuilt functions when EXPR, lit, split, substring, translate, do date underscore format, array, right? Map values, right? And the external sources, working with the SQL statements and with MySQL integration, Hive integration, CSV transformations and actions, narrow transformations, wide transformations. And what do you mean by drivers and what is the knowledge on this drivers, executors, submission of this PySpark jobs, and what are the configuration parameters, window functions, writing data to external sources, deployment modes, applications, driver executors, Spark application pipelines, performance tuning, right? Working with streaming, Kafka, integration with Kafka and MLlib, right? Yes. So in brief, in depth, we'll be discussing, right, about this PySpark. Yes.
So today we have completed the first part.
Yes. So RTD computation, I was discussing, right, how an RTD is going to be computed. And
No,
which
according to this index, have we completed the first part?
so just I was saying RTD computation, this one I was discussing, right? RTD computations. And RTD computations in that, what are the different ways to persist, unpersist, which RTD to persist, what is Spark data objects, introduction to this Spark data objects, this I have discussed. In the next session, first I'll be briefing you about fault tolerance model, different persistence options, more on persistence rules, and fault tolerance model, right? Next, okay, fine. And later I'll go with practical part. Next Saturday I'll be discussing, but Sunday onwards we go with the practical part. So those who have not got enrolled, right? So kindly get enrolled. So next, so for this PySpark, get enrolled.
Sir, sorry,
To get
sir,
the-
we'll use only Python for practical or any
Yes.
other language?
The Python only.
Python, okay. Sir.
So Python, right? So next Sunday onwards, we'll go with the practical part. There won't be any theoretical. So whenever we go with practical, I'm going to take more time.
Projects will be there.
Yeah, at the last, I'll be discussing one flow. Yes. So that's what. So you can see in the chart panel, right? 1 second.
Yes.
You can just see the chart panel, the payment process procedures, and the videos you'll be getting, right? A session video you'll be getting in a Google Drive shared with me option. So
Sir, can we include the project which you will teach in our resume?
yes.
Okay.
So okay. So whatever that clear notes will be provided, the videos you will be getting, right? WhatsApp group, you will be added to the WhatsApp group, right? For fine. So get enrolled to get next week. There will be a change in the link. Check your mails if you have enrolled. If you have enrolled and if you have paid the fees, don't forget to share your screenshot to this online team, DURGASOFT online training, right? You can see the chart. The mail ID is given. Try to give the screenshot of it. You will be getting the new link. So that same link you will be following to up to the end of the course, right? Yes. Fine. So, okay, so this is what introduction to this PySpark and RTD computations, right? Next week we'll go with the practical part, right? And fine, okay. So I'm stopping for now. We'll continue in the next RDM. We'll take more time for the practical part. Yeah, thank you all. Thank you all for your time. Thank you.
Thank you, sir.